We'll do now an introduction. What is the magnetic field? Where do we say that we have magnetic field? And then we'll talk also in this video about the magnetic field created by a magnet. So in the first part, how do we know that we have a magnetic field? So if we place at a certain point of the space, a magnet, where we say a needle, this means that I place a needle, and this needle becomes submitted to a magnetic force, it means I see an action on this magnetic needle, then I will say that in this region of the space we have a magnetic field. Example is, for example, I have this is the needle. وجيت طلعت إنه هيدا الneedle, for example, it's moving. This means what? This means since the needle is moving and around it, I have a certain magnetic field. Now, this magnetic field can be created by a magnet, can be created by the earth, can be created by any other influence. But here, مثلا, the magnetic field is created by a magnet here. Now, the magnetic field is represented by what? It's represented by a vector. So when I say a vector, this means it has a point of application, line of action, direction, and a value. And the value of this magnetic field is in Tesla. The unit is Tesla. Part 2, the magnetic field B can be created by how many methods? So I can have a magnetic field using what? Using a magnet. So what is a magnet? First, a magnet is a metal that can pull certain kinds of metal towards itself. So here, this is a magnet. It can pull certain metal, and it has two poles, which are the south and the north. And also, so this is S and north. And also, I have to pay attention that when I have opposite poles, then these opposite poles will attract each other. But if I have same pole, north and south and south, so these poles will repel each other. يعني إذا جيت جبت two magnet من بعض وجبتهم اثنيناتهم كانوا north same pole, then رح لاحظ إنه these two magnet ما حيقربوا عن بعض كأنه شو عم بيعملوا عم بيبعدوا عن بعض, and this is where we have repulsion. بينما here, this is where I have attraction. Now, other characteristics, the magnet creates around it then an invisible magnetic field. And this is what we said, it's represented by B vector. Now, usually, in order to represent the magnetic field, we use what you call the field lines. هنا عبارة عن lines which are not real. These are only to figure. So هنا عبارة عن وهميين, يعني pictorial only tool to figure the direction of the magnetic field. So, for example, what are the types of the magnets? So as types of the magnet, we have the bar magnet, which has two poles in north and south. And بتطلع هود lines هنا عبارة عن the field lines. So هود عبارة عن fields وهود عبارة عن lines وهميين لحتى يحددوا لي in order to talk about the direction of the magnetic field. The direction of the magnetic field is always from north to south outside the magnet. So if I want to pull, these are the lines. If I want to trace the magnetic field vector, then it's always tangent to the field's line. So here, for example, this is B vector. Here, this will be B vector. So it's always tangent, and this is B vector, tangent to the field lines. Now, another type, we have this U-shaped magnet. So from its name, it's a U-shaped magnet. It has also two poles, south and north, and it's always directed outside the magnet from north to south. This is the direction. Now here we have a certain remark بالنسبة لل U-shaped magnet, which is important وبتعطي a certain characteristic, which is between the here, I noticed that the magnetic field is parallel to itself. Okay, so it's parallel and it has the same value. This is why I say that here in this region, the magnetic field B is uniform. And when I say a uniform vector, that means it has same direction, same line of action, and same value. So in this region of the U-shaped magnet, the magnetic field B is uniform. This means it's a constant vector. Now, here at the end we have the magnetic needle. Now the magnetic needle هي عبارة عن شو? It's a needle in order to give me the direction of the magnetic field. But we must pay attention that this needle, it only rotates, for example, it only rotates about a vertical axis. ولأنه بتبرم على vertical axis وهي حتعطيني which direction، يعني حتعطيني البي أي بي، حتعطيني البي if it was B horizontal. So ما حتقدر تعطيني إذا البي كان inclined، رح تعطيني component اللي هي horizontal اللي له. So it's used to determine the direction of B, and when it's placed on a vertical axis, it rotates horizontally to give me the direction of B horizontal. This means, for example, لنفرض أنا عندي البي direction اللي له it's like this, and I put, for example, a needle. So the needle would not give me the direction of B inclined. It will give me the direction of B horizontal, the horizontal component of this vector.